In this video, we're going to solve quadratic equations using completing the square, and we're going to focus on scenarios where the a value does not equal 1. So let's just start by diving in and trying an example. So regardless of whether or not our a value is 1 or not, when we're using the completing the square strategy, we are always going to start by putting all of our terms that contain an x squared or an x on one side of the equation, and then putting our constant, which are all of our terms that don't contain a variable, onto the other side of the equation. And so we can see that this one is already set up and ready to go for completing the square. Then from there, we have to focus in here on this value that is in front of the x squared. So previously, when we've talked about completing the square, we talk about creating perfect square trinomials. And every time we've seen this before, our a value has been equal to 1. And so it would be really nice if we were able to make our a value 1, which in this case we can do if we're a little strategic about it. So here I see that this number in front of x squared is 2. And I would like to turn that into a 1. The easiest way to do that is to take 2 divided by 2. Now, if we're going to divide that first term by 2, we then need to be consistent and divide everything by 2. So what we can do is we can take the current a value, which may or may not be equal to 1, and if we need to turn it into a 1, we can just divide every term by that a value. So here, if we divide every term by 2, we get 1x squared plus 10x is equal to negative 35. And now this is set up in such a way where it's a little bit easier to find how we can create a perfect square trinomial with those x values. So now I'm going to start thinking, okay, I have 1x squared plus 10x, and I need to figure out what I need to add in here to make that a perfect square trinomial. And the easiest way to do that is to look at that coefficient of that x term in the middle, which is 10. We can take 10 and divide it by 2 to get 5, and then if we take that 5 and we square it, we find that in order to turn this into a perfect square trinomial, that we need to add 25 here to the left-hand side of the equation. Now, if we add 25 to the left-hand side, we also have to add 25 to the right-hand side of the equation. Now, by adding in that 25 to each side, what I've done is I've created a perfect square trinomial of 1x plus 5 in parentheses squared. We have the 1x times 1x, which would give us the 1x squared. Then we would have 1x times 5 twice, which would give us the 10x. And then 5 times 5, which would give us the 25. So here on the left-hand side, we've created and produced a perfect square trinomial, which can then be written in factored form as 1x plus 5 quantity squared. Now on the left-hand side, negative 35 plus 25 is a negative 10. So we have now created something that is a little bit easier to solve, because now all we have to do is solve this for x. So in order to undo that squared that's over the entire left-hand side, we have to square root each side. Now because I square rooted a squared, I know that this right-hand side is going to be plus or minus the square root of negative 10, and that's equal to just x plus 5 here on the left. Now, I do know that I need to simplify this a little bit, this square root of negative 10. 10 isn't divisible by any perfect squares, but we can pull the square root of negative 1 out of there. And we know the square root of negative 1 is just I, so this is going to be equal to plus or minus a single I times the square root of 10 here on the right. Then we have x plus 5 on the left. And then our last step is that we need to get the x by itself. So I'm going to subtract 5 from each side. So we have x equals, I like to write the real part first, so it would be negative 5 plus or minus. You can write 1i or just an I. I'll put 1i in there for those of you that like that better, times the square root of 10. But remember, it could also just be x equals negative 5 plus or minus I times the square root of 10. Either one of those would be perfectly fine. So let's dive in and try another example here. So my first step is I'm going to get all of the x's and the x squareds together on one side of the equation and all of the non-x's and x squareds together on the other. So we're going to subtract that 15 over, so we have 3x squared minus 12x is equal to a negative 15. And now my goal is I need to get this coefficient of x squared to be just 1. And the easiest way to do that is to divide every single term in that equation by that coefficient of x squared, which in this case is 3. So 3 divided by 3 leaves me with 1x squared. Negative 12 divided by 3 leaves me with negative 4x. And then negative 15 divided by 3 is a negative 5. So now from here, I need to create a perfect square trinomial. So I have 1x squared minus 4x plus some mystery number I need to add in is equal to negative 5 plus that same mystery number. So in order to find that mystery number that I need to make a perfect square trinomial, I take the b value, which is the number, the coefficient in front of x, and we have negative 4 divided by 2, which is negative 2. And then we're going to take negative 2 squared, and negative 2 squared is a positive 4. So we have plus 4 plus 4. So then from here, I can see that I've created a perfect square trinomial. So this part on the left is going to be x minus 2 quantity squared. Remember that negative 2 comes from right here. And then negative 5 plus 4 is just going to be negative 1. So now from here, I need to start actually solving this equation. And so in order to undo the squared, I can square root each side. So here on the left-hand side, I just have x minus 2. And because I square rooted a squared on the right-hand side, I'm going to have plus or minus. And then the square root of negative 1 I know can be represented by I, so it's really plus or minus I. Now finally from here, I just need to get the x alone by adding 2 to each side. So I have x equals, I like to write my real part first, so it's 2 plus or minus I. So let's try one last example here. So again, to start, our goal is to get those x values or x squared values together on one side of the equation and all of the constants together on the other. So here, if we add that 40 over, we end up with 5x squared plus 80x is equal to a negative 260. So then from here, our goal is to make this coefficient of x squared just a 1. And because it is currently 5, the easiest way to do that is to divide every single term in that equation by 5. So if we divide everything by 5, we end up with x squared plus 16x is equal to whatever negative 260 divided by 5 is, which is negative 52. So now our next goal is to create a perfect square trinomial, which we can do by looking for what value we need to add into the left-hand side. So we're trying to think through what do we need to add in to make this a perfect square trinomial. So we take that middle term, that coefficient of x, which is 16, and we divide it by 2 to find 8. And then we can square 8, which gives us a missing value of 64. So if I add 64 on the left-hand side of the equation, I also need to add it onto the right. And so from here, on the left-hand side, I've created a perfect square trinomial, which can be factored to be x plus 8, coming from right here, quantity squared, and that equals 52 plus 64, which is 12. So now from here, I need to actually just solve the quadratic. So I'm going to start by square rooting each side. The left-hand side just becomes x plus 8, and the right-hand side, because I square rooted a square, becomes plus or minus the square root of 12. Now when I look at this, I notice that 12 is divisible by a perfect square. It's divisible by 4, because 4 times 3 is 12. So if I split that up, I need to simplify that expression down. So if I write the square root of 12 as instead the square root of 4 times the square root of 3, I know the square root of 4 is 2, so it would be 2 square roots of 3. So what's really going on here is we have x plus 8 is equal to the simplified square root here would be plus or minus 2 on the outside times the square root of 3. And then finally, we just need to solve this. We would subtract 8 on each side. So we have x is equal to -8 plus or minus 2 square roots of 3.